Morning and welcome back again. Today we are going to next step and the last chapter in our journey. The call to is what is about the parametric equations, and you can see there's some name emphasize it. You can see polar coordinate because we got something before. It was what? It was xy or Cartesian coordinate. Now today or later maybe we are going to polar coordinate, another coordinate. Coordinate means some place to sketching and discussing some shapes. Like for example, we have a square and I'm going to discuss the square in the XY plane. So how about the cube? How about, for example, we have a circle. We can deal with the circle in here, right? So how about circle itself? How we sketch the circle without XY plane? We have an angle. So this is all, this is something about, actually about the polar coordinate. Later we are going to the detail. Before we are going to the polar coordinate, we need a parametric equations. So the first of all, what's a parametric? What do you think about parametric? Yalla. Give me some word, clue. Parametric. For example, in the chemistry, we have water. We change to the ice. So what's the parametric to change its temperature, right? Cooling down. So you can say cooling. But what's the main thing is temperature. We decrease the temperature and then we make the freeze, right? So we freeze it. So we change the water to ice. Again, also, by heating, we will get what? From ice, we will get what? Water. So this is called parametric. The parametric here is what? Temperature. You got it? So in that case, temperature, in that case, temperature. But sometimes we can write like that. Wt is equal to I. You know what I mean. So it means that if I use the parametric, I will get something else. You got it? Before we have what? F of x is equal to x squared, right? So now how about f of t equal cosine t, sine t? This is called, and of course I say t is between what? Between 0 to, for example, 2 pi. It looks like what? I have water, and as an assistant, we have a temperature. And if I heat a for example, I want to get in ice, I say T, let T be between, for example, minus 100 to 0. You get that one, right? Because I want to make a water. I want to get the water, get the ice. That's why. Or vice versa is also true. You can from use WI, you will get a T, something else. So T is a condition, or I is like a temperature, or like something like that. Sorry, Taman, I is between that one, not T. T is at the assistant things, help us to change something to something else, or help us to get in the continuation of the function. For example, if I say f of x is equal to x squared, when I say x is 2, I know I will get 1 point, which is 4. But when I say x between 0 and, for example, 2, I know I will get many points, right? I will get many points from here to here. So that's why that is a continuation of the things. So you say, for example, the car or the something is going to between minus infinity and infinity. Means that t is belong, or x belong to what? To R. Means that we will not stop at any points. We are going to here and there without stopping. So this is the parametric as a general idea, as an introduction. Do you get the idea? You got it? Do you have any questions? Question? No, good. So this is the parametric. You can see here we are going, for example, on the path, And the parametric sometimes in the physics is what? Time, right? We have a car change or moved from that point P1 to that point P2. And you have a car, here's the car, is going to be here. So maybe in the math, our focus on the distance. We have one things. But in the physics, beside the distance, we have something else. What? Another parameter, time, right? Time here's 0. Here's after what? After, for example, an hour, right? And also we have a kilometer. Kilometer from here is 0, the distance, and here is what? For example, 2 kilometers, you know. So you can see at the same time you have 2 variables, 3 variables. So we will change it to the parameter and we will solve it. So that's the benefit of the math. You will give things and then they will put the modeling in the physics, in the chemistry, whatever, in the medical science. They'll use the modeling. After modeling, they will give it back to us. We will analyze it and we will give them the results. That's why I say the modeling. So you can find many applications about the modeling. Good. So here we are. We have a parametric equation. Some of them is easy, some of them is not. So we have a parametric curve, we have a parametric equation. You know, curve means something like that. Equation is a general form. You can see from here, sketch the curve defined by the parametric equation. You can see we have a start point, or sometimes say initial point and the end point. Here's the initial and the end point, and we have y is equal to t. You can see here, y is equal to t is like what? If you sketch the graph, you will get such things going to up till 6. Why? Because I know if I say y equal to sine of x, I will get what? The graph is like what? Right? It's like that. So how about if I change that one? I say x is equal to sine of y. The graph will be on the y-axis, right? You got it? Hello? Good. So that's why I have what? I start from, instead of like that, I start from here to there. But because I have a start point, initial point, so I'm going to start. If I put if I put t be 0, I'll get what? Here I'll get 0, right? Sine of 0 is equal to what? 0. So that's why we will start from here, 0. Then if I put 1, 2, 3, it will be increased till what? Till 6. So that's why we will get the points here. For example, if I include, I say t between 0 means that 0, 1, 2, or 0.1, and go until t is equal to 1, t equal to 1.1, and go on. When I put t1, I'll get what? Sine of pi over 2. Pi over 2 is equal to what? Sine of pi over 2? 1. You are right. So in that case, I'll get 1. Now you can see if t is 0, x will be 0, it's a function, and y also will be what? Well, 0. So I'll get 0 and 0 point, right? So here I am. Okay, now let me erase it and use the red pen, the red color to get more. So here we are 0 and 0. Okay, when t is 1, I will get what? I'll get 1. So, and also y will be what? 1. Why? Why is y 1? Because y also will be 1. So I have two functions. X is equal to sine t pi over 2 and y equal to only t. So when I say t be 0, I'll put 0 to here and 0 to here. I'll get 0 and here will be sine of 0. Then that's the point x and y axis. I'll get 0 and 0. When I say t be 1, sine of 1 multiplied pi over 2 means that sine of pi over 2 is equal to 1. And here's also be 1. So I'll get 1 and 1. That's why you can see from here at 1, we have 1, 1. And go to 2, go to 3, go to 4, go to 5, and final one, go to 6. If I put 6, I will get what? If I put 6, I'll get sine of 6 pi over 2, right? 6 pi over 2 is equal to what? 6 pi over 2 is equal to what? is equal to 3 pi. 3 pi is equal to what? 0, right? Sine of 0, pi, pi over 2, 3 pi over 2, right? Sorry, 2 pi, 3 pi, 4 pi is like that. It's equal to, it will be equal to 0. That's why we get a 0 each time in here. So 1, 2, 4, 6, we will get 0. And that's all the point that we will get it. Otherwise, and that between all these points, it will be continuation between them. How many students understand from the first example? Kindly raise your hand if you didn't get the point. You didn't get the point. Okay. So let me do it. We have sine of x. And when I say x between 0 or 2 pi, for example, okay? So we are going to replace or substitute these numbers. It's okay. These numbers, thank you. So I'm going to say, I say x and y, and I'll get the point, right? Okay, if I say x is 0, I put 0 here. So if I say sine of 0 is 0, the point will be 0, 0. When I say, for example, sine to be 1, it will be sine of 1 something, and a positive number. And here will be a positive number, so I have two small positive numbers. But when I have b pi, sine of pi over 2, here I am, I know when x is pi over 2, the number will be what? Will be what? Then I will get what? Pi over 2 and 1. For sketching that, I have 1 and I have 0, for example, here. The first point will be 0, 0. The second point will be something positive, 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 till here. Here, when x will be pi over 2, replacing the result will be 1. So that's why I'll get 1. And at the end, later, it will come down to here and down to there, right? And I'll get what? Minus 1 and what? 3 pi over 2 and minus 1. And here will be 0 and pi. Sorry, pi and 0. And here will be 2 pi and 0. You know about that one, right? Easy. Now we change the graph. If I want to change that graph without any hesitating, without any change, without any making more complicated. If I say x is equal to sine of y between 0 and 2 pi. The graph will be like that on the y-axis. Again, x will be between 1 and minus 1. Y will be like that. You got it, right? Okay, so 0, 0. Here will be what? 1 and pi, right? 1 on pi over 2. Here will be 0 and pi. 0 over x and pi. Here will be what? Minus 1 and 3 pi over 2. Here will be what? 0 and 2 pi. The value of y changed. You got it. Understood, Jama'at Damash? Hello? You got the idea? Good. Now I am going to make it to new chapter, to parametric equation. How? I have parametric. I have t between 0 or 2 pi, you can say, or to 6 or to 5. Any numbers, okay. Just number. And I have two functions, x and y, depending on t. That's why you say parametric. Ice and water. You remember that. So I have ice. Here's parametric. And I have water, for example. Just t. Maybe t plus 1. We don't know. Depends. So, and he says sketch the graph. At the beginning, because I have x is equal to sine t, I know the x will be like that. The graph will be like that. Am I right? Understood. And how about the value of y? I have a value of y because I have another function. Here's the function number 1, water, and here's the ice. So how we deal with that one? We replace the t. So I have t as a first variable, the parametric variable. Also, I have a x, which is equal to sine t pi over 2. Again, I have y, which is what? Just only t. Am I right? And then I will get the point. So if t is 0, I'll put t here. So sine of 0, 0 pi over 2, you'll get 0. And of course, you see t 0, it will be 0. So the point will be 0, 0. Then later, tb1. When I have 1, I will get sine pi over 2. And I know sine pi over 2 is equal to 1. And because you put t here, I'll get 1 again. So I'll get 1 and 1. You go to Jamaat? Yes. It's better to take the integers at the beginning to get the idea. Then later we will continue between them, right? Like a sine. We do 0 pi over 2 pi and go on, right? 3 or 5 main points, like a max and min. The others, you will know how to sketch it. You can connect them. So if I will get, if I put 2, here will be 2. How about here? Sine of pi, and I will get 0. So it will be what? 0 and 2. If I put 3, yalla. Of course, I'll get 3 here, and I'll get something with 3. I don't know. If I put 3, I'll get sine of 3 pi over 2. Sine of 3 pi over 2 is minus 1. So here we are, and go on. So how we sketch these points? I say on x-axis, sorry, I have 0, 1, 0, minus 1. So 0, 1, 0, minus 1. How about y-axis? I have 0, 1, 2, 3. You can see 0, 1, 2, 3. Okay. Now sketch the points. 2, 3. Now sketch the point. At the first point, it was what? 0, 0. How about the second point? 1, yeah? 1 and 1. Here's 1 and 1. 1 and 1. How about the third point? 0, 2. Again, I am here. How about the third one? Minus 1 and 3. How about the fourth one? 4 and 0. How about the 5? Like that. So if you, and you'll get the shape. Understood? So this is about the parametric. What's the difference between that equation and the previous one in the cal one? Just we have t, right? We have a t, like a radio channel. We will have a t going to that one to get the point. Question again. Yalla. Question. Good. Now I have another question. Another scale the curve defined by the parametric equation. There's your question. What's x? T squared. What's y? T plus 1. How we solve? Okay, forget about the calculus. How we, before, in the secondary school, how we sketch the graph? Grade 8. How we sketch the graph? Exactly. How we did in the example number 1, right? By substituting the point. Point to x, point to y, you get xy point, and you sketch it, right? But that one's accurate? No. Because, for example, for x squared, if you want to sketch it, how many points you want to take it, right? Even if you do it, for example, you say y equal to x squared. Sorry, you can go to here. Now we are in the grade 8. I'm going to just review grade 8. So, for example, when you see I is equal to squared, and you substitute the points, right? X and y. You say it's 0, 0, 1, 1, 2, 4, 3, 9, right? When you sketch the points, you say 0, 0, 1, 1, 2, 4, 3, 9. It's not accurate. Understood? Even for the negative part, it's not. It look like, I don't say, but it's not accurate. It's a sharp. It's not like that. So how we get the point after practicing putting many points, then we will get. But it's not easy for the students in the grade 8. So that's why the shape it's better to be like that. But later we got the number, more numbers, right? Because we know between 0 and 1, how many numbers do we have? Infinity. So we have infinite numbers here. So it makes a curve. You got it? A little bit smoother than the other one. The other one was sharp edge, just line like that. but now it's smoother. So for that example, it was like that. At the beginning, we just do like the ding dong, right? We get here. But later we know, because it's like a sine is the curve. We make it what? We make it smoother. We make it to look like the curve. Understood? Okay. So tell me about the second example. I don't know. I don't say it's not a perfect way. T is what? T is R. Take many points. So it's not possible to put the 1, 2, 3 and -1, -2, -3, right? Maybe it will give you something, but not all things, not the whole picture. So how we do it? How we do it? We need to find the relation. Okay, we need to find the relation. How? Look, we have x is equal to what? T squared. Y equal to what? T plus 1. So T is equal to what? From the second equation. Y minus 1, right? Okay. Let me use another easier one. From the first equation, I will get what? X is equal to what? Am I right? Am I right? Good. So, sorry. Square root of x. Well, okay. So, I can see, put in, let me do it. Actually, I think about it. Also, I don't know how to do it. So, I see from number 1, number 2, from equation number 1, t is equal to square root of x. All right, good. And put in equation number 2. You'll get what? Y equal to what? Square root of x plus 1. Right? And now it's easy. Why is easy? Because you know how to sketch y equal to square root of x. Am I right? In Calvin especially. So this is the plus 1. Plus 1, shift to up. There's R. So the graph of y equal to, sorry, x is equal to t squared and y equal to t plus 1 when t belongs to R means that from -infinity to infinity, it's like that. Understood? So what did we do? Your mobile away? What did we do? Which exact by what? Finding the relation between what? X and Y. How? By substituting t in one of them. Make t in the left side and the other, I don't know, maybe Y, maybe X, I don't know. Then you will get the relation, then you will get the calculus one. So here we are, we change it to like that. Isn't easier than the previous one? Without thinking, without putting one here? Time consuming. So you can see, you can use that one or you can use that one. Okay. So tell me about when I took here, t is equal to square root of x. Is alone? No, of course not. Why? Because we have plus, minus. And the plus minus means what? Value. So the value will be what? If I have y equal to square root of x, how about y equal to minus square root of x? The square root of x is like that. The minus is the reflect with the x-axis. So I'll get like that, okay? So now I have what? Plus 1, plus 1. So the other part will be reflect of my graph. Understood? You get it, dear? Easy? Good. Now this is for the negative part, that one for positive part, that one for positive part, and that one negative part you can see. And look at the example 3, which is a common example. Maybe it looks like a different, but it's easy. X cosine t, y sine t, and we have what? We have t between what? 0 and 2 pi. In that one, you can think about it and substitute, or directly you say is what equal to x is equal to cosine of t, y equal to, on first equation, sine of t. T is what? T between 0 and 2 pi. So I have what? T, am I right? X, y, and what else? XY point. So I say t be 0, cosine of 0 will be 1, right? And y will be 0, so I'll get what? 1 and 0, and go on. Then, for example, t is pi over 2. There will be 0, am I right? And that one will be what? 1, so I'll get 0 and 1, and go to pi. I will get -1, and I will get 0, -1 and 0, and then till 2 pi, I will get 0, and I'll get what? 1 again. Am I right? No. No, I'm right. So I forget about what? 3 pi over 2. I'll get 0, -1. Then it will be 0 and -1. Then go to 2 pi. I will get what? 1 and 0. You are right again. Then let me do just the only important points. I say it's like that. Why? Because I'm going to select that point. It will be 1 and 0. How about that point? 0 and 1, -1, 0, 0, -1, and again to here, right? So if I connect this point, I'll get an equation of what? Equation of circle. Understood? And I look at the relation. I have x equal to cosine, y equal to sine. Okay. Now, x squared plus y squared is equal to what? Cosine squared, right? Sine squared. Am I right, Kaka? And sine cosine squared is equal to what? So x squared plus y squared is equal to what? What's the equation of what, that one? Circle. But which circle? We called unit circle. When I say unit, 1 unit, I mean 1 unit. Means that the radius is what? Only 1. Am I right? So both cases, I got what? Circle. So now in my mind, when I have x cosine, y sine, I say the equation will be what? Circle. Understood. How about a? A is any number. Okay? So that is the equation for unit circle. That one for circle, generally. The radius here is a, the radius here is what? 1. You got it here. So here's the example. And you can see we have such point. So another example to find the relation between, or sketch the graph. And there's, in the exercise, there's actually many and hard, but we are going to choose this simple that's connect with the calculus one, okay? A little bit thinking, no more. So tell me about that one. Do not think about the point. Think about what? Relation. Why I didn't say think about point? Because you start from 0 to where? To infinity. Yes. Y is equal to? Y equal, yes, you're right. Y equal to x squared. But do not forget, x should be what? Positive. Why? Because when you substitute here, never get that what? Negative part. Because if I don't mention that one, my graph will be what? A little bit, you need a little bit be careful, no more. So this is my graph, am I right? But when I say x greater than or equal to 0, I know one of them will cancel. We see reducing domain, cutting domain. Why? Because I have a condition here. Never get a zero, negative part. Okay. So it means that x never get what? Negative part. As well, y isn't what? Positive and zero, right? So both case, I don't have a negative. That's why when I say y equal to x squared, 100% you are right. But what? But after, what do you say? After replacing. So do you know how y is equal to x squared? Dears, do you know how he do like that? Okay, good. So you don't need to mention. Or let me just mention, because you are recording, maybe some in the other group they have a question. So just let me do it for 1 second. From equation number 1, I'm not going to, I say what? I say x equal to square root of x. So t equal to what? X squared. So put in equation number 2, I'll get y is equal to x squared. Do not forget about x greater than or equal to 0, and thank you. Okay. So, yes. So just we have the parameterizing is given. For example, in your exercise, if there is no things about t, I don't know if we have or not. Just let me check it. Because in the previous edition, some exercise or example didn't mention anything about t. Let me just check it for 1 second. Mostly from here, you can see. Sometimes they didn't mention t. T is where to where. On here, mostly t is between, you can see between pi over 2. But in example, if I don't say anything in exercise or the quiz, if I don't say t is belong to where, means that t belong to r. Means that t is all values. Understood? So that's all about the parametric equation and 11.1. Do you have any question about here?